Good morning, ladies and gentlemen. Welcome to week 7 of distance learning in chemistry. I am your host, Mrs. Rubalcaba. Okay, let's get started. So the agenda for today will be the same as always. Our usual reminders, the assignment overview, and we are going to go on to our lesson. So make sure you have at least a pen or a pencil and paper if you are going to write your solutions down rather than typing them in. So on to our reminders. Take your attendance every day, once per day. Flex hours, Mondays and Tuesdays. Mondays are for periods 1, 3, and 5, and Tuesdays for periods 4 and 6. Please join my live session the very next day. That is a way for you to check your answers for the assignment. Please complete and turn in your assignments by this Sunday, 11:59 p.m. So the assignment overview, your assignment should look like this. It should say 5.3 acids, bases, and salts, part 2. The options for turning in your work, either take a picture of your handwritten work and attach it to your assignment, or type directly on the document, whichever is easiest for you. Okay. So 5.3 acids, bases, and salts, part 2, the second part of this chapter. So this is your catalyst question. How do you measure how acidic or basic a solution can be? And I'll give you this image as a clue. Okay, moving on. The objective for this week, students will be able to determine the results in acid-base reactions and neutralization processes and learn the significance of the pH scale to changes in concentration. In other words, you will learn how to predict the products in acid-base reactions, do neutralization calculations using this new variable, capital N for normality, and also you will learn how to calculate pH, pOH, and their relative concentrations. Your standard is also from HSPS 1-2, explanation for simple chemical reactions. Now, these are the products of acid-base reactions. This is what normally happens. So with a strong acid and a strong base, you would normally get a salt and water. So strong acids and also strong bases, they are going to dissociate completely. And when I say dissociate, it means that those ions will separate completely in the solution. So as strong as they are, they will be able to break apart easily. For example, hydrochloric acid is a strong acid and sodium hydroxide is a strong base. Okay, let me move my head here. Sodium hydroxide is a strong base. So these two are strong acids and bases that will dissociate completely, which will result in the salt that we all know, sodium chloride, and also water. Now, if a weak acid and a strong base were to mix, you would normally get a more basic solution as a result and a possible soluble salt. Now, weak acids and weak bases, they won't dissociate completely. Only a few of those hydrogens and hydroxide ions will separate. And when it's a strong base, then you would expect that the resulting solution will be more basic. For example, this is acetic acid. This compound here is acetic acid. And that is a weak acid. And if you guys remember what acetic acid is, it's vinegar. When acetic acid, a weak acid, is mixed with a strong base like potassium hydroxide, what you would normally get is a lot more of these hydroxide ions being mixed in the solution. So it'll be a more basic solution. And this possible soluble salt, and it does occur here, and you can see that the potassium here dissociates from the hydroxide and replaces this hydrogen ion here. In other words, this is what is known as your double displacement reaction. Again, more previous knowledge that we have to go back to. Now, the other way where you have a strong acid mixed with a weak base, you can guess that the resulting solution will be more acidic and also a possible soluble salt. Okay. So this is your example. Hydrochloric acid is your strong acid plus ammonia, which happens to be a weak base. And you will have mostly a acidic solution plus this soluble salt here. Now, if it's a weak acid and a weak base, you can guess that there's hardly any dissociations going on, and it will mostly result as a neutral solution. So let's put our weak base there and a weak acid, okay? And you will end up with a neutral solution with a little bit of ions dissociated. So you guys are supposed to be able to predict products in acids and base reactions. So let's do this first one together here. So what I want you guys to remember for acids and bases, let me get my pen ready. For acid and base reactions, it is normally a double displacement reaction. Double displacement reactions, remember that it's like partners switching and swapping. And also you can try to see if a water, okay, H2O, and a salt will be the result. So let's take a look over here. We have a hydrogen here and a potassium. These are your positive ions. And we are going to separate those positive ions and switch partners. So what you're going to see here is this hydrogen is going to join this hydroxide, and we'll end up with H2O. That's your water. Okay. And this potassium will join with this chlorate here, and you will end up with, and that's an L, okay? You will end up with this compound. Okay, so let's go back and see and make sure that everything is balanced. We've got two hydrogens here. We have chlorine, one chlorine. We've got the O4 and the chlorate. We've got O4 here. Seems like everything is balanced. Now, can you do the next one on your own? Magnesium hydroxide plus hydrogen sulfide. Okay, so remember, you will normally see a double displacement reaction and also the result, water and salt. So let me start you off actually. We've got a hydrogen, we have a hydrogen here and a hydroxide. You can see that you can turn that into a water and try to figure it out on your own and come to my live session the next day to check your answer. So now on to the concept of neutralization, and just by the word itself, you can figure it out that it's turning everything neutral, as in not acidic and not basic. So it's a chemical reaction that results in a neutral solution, middle of the road, okay? So it's going to be acid and base, which will result in a water and salt. Now with neutralization, an acid and a base will neutralize. When they are combined, that's because all of the ions will reorganize themselves to form neutral components. And the number of hydrogens in a neutralization reaction must equal the number of hydroxide ions so that they can form water molecules. So the other ions, the remaining ions in the solution, will then bond to form salts. So the negative, those anions from the acids, will form bonds with the cations of the bases. And that will be your salt. So the definition of a salt in a neutralization reaction will come from the acids and bases, the negative anions from the salts, from the acids, and the positive cations from the bases. Now, this issue of normality, the new variable that I want you guys to learn about, it is very similar to molarity with a small difference, okay? Now, the purpose of using normality is when we're dealing with concentrations of acids and bases, and we're going to need this concept to find volumes of acids and bases. So we know that in molarity, it is the moles of the compounds. But in normality, it's the moles of those ions. So those compounds have been broken apart, but we're going to take each ion into account. Okay, and like with molarity, where it's moles per liter, this will be the moles of ions per 1 liter as well. So, for example, we have this base, sodium hydroxide, and it's going to dissociate into these separate ions: sodium, which is a positive ion, and the hydroxide, a negative ion. Now, let's try to figure out how many moles there are for each ion. So each ion is actually 1 mole. Why? Because there's only one ion, one sodium ion that forms for every 1 hydroxide ion. Therefore, the normality of sodium ion is 1 mole per liter, and it is represented by the capital N. And the normality of the hydroxide is 1 mole per liter, okay? So we are going to take into account how many ions there are that makes up that compound. Now, let's take a look at this. This is sulfuric acid. It's a pretty strong acid. And it dissociates into the hydrogen ions and the sulfate ions. And we have the 2 over here to make sure that this is all balanced out. What is the normality? I almost said molarity. What is the normality of the hydrogen ions? And what is the normality of the sulfates? If you guess that there is 2 moles of ions, it's 2N for the hydrogen ions, you are correct. If you guess there is a 1 for the SO4, the sulfate, you are correct. Now, with these neutralization calculations, we have this equation that we will use. And if we find all of the values, we can just plug them in and find the unknown values. You're just going to have to know what each one of these parts mean. So for the neutralization calculations, it will be the normality of an acid times the volume of the acid equals the normality of the base times the volume of the base. All right, so what I want you guys to do right now is to go back and review the concepts of neutralization and normality, and also the products of acids and bases. Take a little break and watch my next video on how to do neutralization problems. See you soon. Where is it?